way we hope to do. Can you all hear me okay in the back? All right. My family's never accused me of being demure and quiet, so I think we're going to be all right. Welcome to Social Networks and Health 2024. We really appreciate you being here. If the folks near the door, once we get started, can just pull the doors closed, that would be awesome, because there are people doing real science out there in the room, and they don't want to hear us. So that would be all right to make sure we are there. Couple of quick just preliminaries. If you're here for something other than social networks and health, welcome to some coffee, and you might want to find another room. Otherwise, you're locked in here with us for the rest of the week, and it is going to be a lot. Spend some time getting to know each other and say hello, and sort of make some connections. That's part of the reason we're here, and we'll make a few things about that as we go. A couple of bits and pieces. There will be breaks throughout. The bathrooms are down the hall and sort of in the middle section right past that little kitchen. And there's also some on the other side over there. If you would rather not take the elevator, there are 2 stairwells that'll take you up and down, and so you can do the stairs as well. If you were wondering yesterday and you came in the afternoon and you thought your ears were ringing, those are cicadas. That's Route 13. They are going to be here, and you will see more of them than perhaps you want, but they're kind of awesome, really. So I hope you get a chance to see some of those. What else to say is the food is in the back. Help yourself. We're in the South. You're going to be well fed. There should be no problem with that. If you have restrictions that we haven't met, please try to let us know as best we can. We are reasonably good social network analysts. We are not professional party planners or social organizers. So we will make mistakes. There will be things that bump and don't work quite right. Please try to be forgiving. As a great example, we somewhere in the cosmic universe, the T-shirt people decided that we needed Carolina blue T-shirts, for example, at a Duke social event. So there you go. If you're looking around and you see the people who are here to help you, which are all the DNAC RAs and former alums, they're wearing now Carolina blue T-shirts. So if you find yourself like with the blue screen of death or something's not working as you're going through this stuff, flag them down and they will help you. That's the strategy. And the plan this morning is to go through some basic overviews and backgrounds to social networks and what this sort of thing is and what we're engaged in. The schedule is sort of set up, as you'll see. I'll walk through it in a bit, and we'll go through some of the elements in the schedule. But basically, we're going to walk you through the process of from getting an idea to getting an analysis done. And I'm going to say this many times, you're not going to get it all in this 4 days, right? So coding and thinking in networks and all of this any kind of method is a discipline. A discipline requires practice. So don't treat this as the end. This is your initiation. This is where you start. And we hope you don't become strangers after this and turn off into isolates, but instead keep in touch and let us know what you're up to, and we will we'll help you move on as we go forward. Question. One other element. Anybody that's parking in the chemistry lot that we wanted to pass and got one, make sure you printed that pass and put it on the dash. If you just put it on your phone and got in the gate, you would think that would be enough so you didn't get a ticket, but the guys that walk the parking lot don't know how you got in the gate, and so if they don't see it, they'll give you a ticket. We can probably fix it if that happens, but it'd be easier for it not to happen. So if you're in that situation, flag down one of the RAs, and we will get you a printed version of that and make sure you're okay. Any other snafus or problems before we get started? All right, let's go. This is the basic outline. I'm old school, I can't help but put an outline up before I start talking, so this is where we're going. I've started my RAs laugh at me every time I put this up. I've probably started every talk I've given since graduate school with this quote, which is to speak of social life is to speak of the association between people. They're associating in work and in play, to love and to war, to trade or to worship, to help or to hinder. It is in the social relations been established that their interests find expression and their desires become realized. This is what you might think of as the strong program in network identity. What Blau's point is that what it means to be a human critter is we're not what's, we're who's. And who's are defined by their social relations. The essence of sociality is our connections to other people. And yet, the vast majority of our methods start with the statistical assumption that people are independent atoms by themselves with little brains that do their things and interests, and they maximize those interests, maybe with some input from others, but by and large, that's noise. Our goal today is to think of that and flip that script. Our goal for the course of this week is to think that what we're going to do is take seriously the fact that humans are social. And by virtue of being social, everything that we do is contingent on the things around us that are being done. Our roles, our connections, our patterns, our beliefs, all of these get spread through our connections with other people. And that's where our interests find expression. That's really what we are. And so that's the goal, the big picture goal as you think where we're going. And of course it's important for something like how I think of myself or who my family is or which kids I want to care for most. Right? So these kinds of features, of course, are always there. But also our health. Like, do I think smoking is a good idea? Do I think it's a good idea to take the stairs? Right? What kind of food do I eat? What kind of beliefs do I practice? Right? All of these things that shape how we become who we are and how we take care of ourselves are also functioning through networks. And that's how the social networks and health idea came about, and that's what we're trying to go for. The history of this field is old. Right, so it started as a sort of recognized thing. Social network analysis probably started in about the 1930s. There's some earlier stuff in that on kinship networks. But Jacob Moreno had this great sort of push to get this idea. He called it sociometry. And he had this notion, he said, if we ever got to the point of charting a whole city or a whole nation, we would have a picture of a vast solar system of intangible structures powerfully influencing conduct as gravitation does in space. Such an invisible structure underlies society and has its influence in determining the conduct of society as a whole. That's the promise, right? So that's what we think. Like, he's looking out at all these great physicists that are predicting the orbits of the planets, and he thinks, well, why can't we do that in social life? And so that was his goal. Turns out, it's a kind of big, complex, chaotic systems aren't as easy as we might expect, and so the promise of this, I don't think, has even quite yet been realized. But that's the goal. If we can identify what these networks are, if we can map them in a particular way, then we can situate people in the right spot and figure out what their constraints are and somehow use that to our advantage to understand the world. And so that's what we're doing. If you're curious in the history of science, this was originally in 3 colors that had social relations and who you liked, who you disliked, and who you spent the most time with. And it's about this size in real life, a little bit bigger, and drawn all by hand. So if you thought you have a crappy RA job, there you go. So. We do a little better than that now. Networks as a field has been increasing overall. This is papers on networks and health as a proportion of all papers of health. Ashton Verdery and I put this together a few years ago. We have a paper out on this, sort of the study of the field that I think I sent around in the resources. One of the things that's, of course, interesting is, well, you're making a big deal out of this, Moody. It's only 5%. But as that goes, that's about equal to the number of papers on obesity in health. Right, so there's been a really strong interest in the field in understanding how these things matter, and so that's what we're trying to work on. If you have a more pecuniary interest, NIH and NSF are interested in funding this work, so the trends are working in the right direction. We can only hope they keep going that way, so that's what we're working on that. So what is a network? How do these things, what are they and how do they make sense? This is a high school. I assume most of us went to high schools. Your high school may or may not have looked like this. Mine didn't have palm trees. But we often think about high schools as these big buildings or maybe a curricula or something like that. When a social network researcher thinks about a high school, this is what it is. So to me, this is a high school. You're going to see a lot of these diagrams today, and I'll go over how to make them eventually. But just for now, the way to think of them is each point is a node, it's a person. In this case, it's a high school or a school student. And the layout, where there's space on the page, is a low-dimensional representation of this multi-dimensional object. And so each node is put near each other on average if they have lots of ties with each other or lots of ties in common to other people. And so the x and y axis don't matter. I can flip this, I could rotate it, it'd all be the same. But what matters is proximity. And the first thing you'll notice if you look at a graph like this is that you can see that the junior high up here, the 7th and 8th graders, are separate from the high school, which are the freshmen in blue and the seniors down here in yellow. And so you have this gradient from 7th grade to seniors. But you'll notice there's also another clustering, and in this particular school, it's race. So if you go to this school, in this high school, even though it's integrated at the aggregate level, if you were to look at what the building is saying, that this is almost a 50-50 split between white and black students, it actually ends up being the case that the odds of a white student interacting with a black student are about as high as the odds of a junior high kid working with a high school kid. So this is the setting that is segregated internally, even though it's integrated formally. And that's something you see from a network standpoint, right? It just pops out from it. I didn't cook the books and lay it out this way. This is what the data tell us. And some schools are like this, some schools are not. Some schools you have integration, some schools you have segregation, and it's that kind of a network context that shapes the way that people think about race and identity and so forth in the setting that they grow up. And that's the kind of thing we want to play with and understand. So social networking, this is the same thing I said before. So the fact that despite the fact that we know this and we believe this, most of sociology and social science has ignored it. We treat people as if they don't interact with anyone else. And in fact, our whole methodological assumption is of independence. And we want to do something a little more than that. And so how do we go about doing it? The process of social network analysis is to define this set of relational methods for systematically understanding and identifying connection among actors. It's motivated by this structural intuition, this idea that the shape of that unobserved structure matters for someone else. And once we think about what that structure is, we need to get data about it, and we have to find a way to understand it. We tend to do it either graphically with these kinds of pictures, which there's a lot of work you can get qualitatively out of just simple visualization, and there's also a lot of mathematical and or computational models that we're going to spend most of our time today working on, or this week working on. If you're not a sociologist, and you're going to get more sociology today than you probably care about, for those who are not, and you're a health researcher and you think get to the practical stuff, there's a new movement, sort of new for us anyway, in the over the last 20 years, has been this notion of the social determinants of health. And networks are one part of the social determinants of health. And if you think about what leads to someone's health and well-being, or the distribution of health and well-being in the population, the context and the setting that they live in matters, but also where they fit in their social life, and sort of what that is engaged in. And the social position idea leads to all these other outcomes, which then in turn lead to the distribution of health care. So thinking about this social distribution and the social determinants of health really matters. There's another reason that it matters, which is that if you're an interventionist and you spend a lot of time trying to figure out how to make people healthier, you're going to do things to them. Like you might be a doctor who takes care of the patient, and then you figure out what your readmission rate is at the hospital and hope that you don't get in trouble with the NIH, right? So that's the kind of model we typically have. The point, of course, is that when you treat a patient, those patients are also dealing with their family and their friends and their neighbors, and they say, that doctor was great, it really wasn't so bad getting a colonoscopy, you ought to do it, like it's a great idea, right? And if they have a great experience, they'll tell their friends to do it, and we'll lower cancer rates. If they had an awful experience, they'll tell their friends about it, they won't do it, they'll die of cancer. And that'll be the doctor's fault for the spillover. So you think about these processes, right? This is actually both a cost and a benefit. It turns out that a little bit of investment on the individual level gets multiplied by that spillover effect. So what looks like a small effect at the individual level gets multiplied by every person they connect to. So we think about networks not just as all of these constraints that are encouraged on the input side, they're also on the output side. It creates this nice spillover effect that allows us to multiply the things we do, both positive and negative. So how do we think about networks in this context? For the health process and for analysis in general, I like to think about networks as sort of two different versions. And I'm going to focus on these ones. This is what this notes connections and positions idea. But I think that another way to think about it is this idea of networks as variables versus networks as structures. The networks as variables approach is probably fits best in the public health model. It says, look, we're going to go out in this world, we're going to measure a structure, we're going to put it into a model, and we're going to see its effect. Pretty straightforward. The network of structure idea says, let's figure out what this pattern is and what accounts for it. How does it come to be? It's like, so what is it why are some high schools segregated and other high schools not? Well, that's an actually interesting empirical question that we can't really make sense of by just thinking about the variables that the kids are engaged in. So we need to find a way to build it. One way to think about the networks and health problem space is to think about it as an inherently multi-level process. And I like to think of this as a general rubric for all sort of network problems, which is that the way we're going to work is we start with a set of behavioral assumptions. Those behavioral assumptions have to do with how they form ties, how we have belief practices, and these are more or less, depending on the field, more well grounded in data we're able to collect. Those things create patterns of micro-networks. Who we're friends with, who we talk to, who we trust, who we dislike. Like those micro-patterns are driven by our behaviors and by our experiences. These are reciprocal endogenous behaviors. Those things aggregate then. So the whole point is that we don't just do our friends that we like, but our friends have friends that we don't have, and those aggregate up into these patterns of macro-networks, which then creates an outcome. Now, I stole this image from a paper from a long time ago, so if I'm writing myself, I would then put another recursive arrow back over there to behavioral assumptions, but there you go. As a classic example in the field is the notion of what's known as social balance. And so we have these aphorisms, right, that a friend of a friend is a friend, and my enemy's enemy is my friend, right? What that means is that a friend of a friend is like we're all chummy together. My enemy's enemy is a friend means that we segregate off and apart. And so depending on which of these two balance out most, you're either going to end up with a lot of chums or balanced opposition. Right? So that behavioral assumption and how it works through the aggregation process creates political segregation. It creates enemies. It creates this whole notion of segmentation in societies can be explained by this very simple notion of that. Or it might be that people adopt the behaviors of their best friend. And so I don't know what to do yet. My friend does whatever green is, so later I become green. That leads to certain kinds of segmentation, right? And so there's lots of these different processes where it can happen. And so the behavioral assumption is your theory, and that's your job as experts in your field. If you're trying to figure out, cancer or HIV or smoking, like there's 1,000 different fields that you need to understand that figures out what your behavioral assumption is, what you think people do and how it affects their relations. And then the network analysis will get you through the rest of this part. That's your theory, right? You have to start there. I can't give you that. That's not what we do. We can help you. Welcome to Bounce. We pretend to know a lot about these things, so feel free to bounce these ideas off us. But this is sort of the part that we're going to focus on as we move forward. So if you take a 30,000-foot view of what is social network analysis, there's basically two types of problems in social network analysis. The first is a connectionist point of view, and the connectionist point of view is really focusing on how things move through the network. So the diffusion of disease is the archetypical example. And so this is networks as pipes. We have this structure out there, things are moving through those things, and that's what pushes the world as we go. Right? A positional network is networks as roles. The idea is that we have sets that people occupy different parts of the network, and those parts of the network create a different sort of set of incentives or opportunities. From the connectionist standpoint, everyone who's gone through the pandemic, right, probably recognizes this little guy, right? We've lived with R naught longer than we care about. R naught can be thought of, there's other ways to think about it. One way to think about it from a network standpoint is that it's the combination of three features. It's the infectivity of the disease, it's the likelihood of contact, and it's how likely or how long people are connected in that way. So those things together, if you balance them out just right, will give you the reproductive rate of the disease, whether it increases or decreases. One way to think about where that goes then is imagine that the contact part, right, what C is the network, right? So from a diffusion standpoint, C is the network. This might be a network you could imagine sampling of HIV or other kinds of sexually transmitted diseases, and you want to understand where the disease moves, and so you sample a bunch of people in your population, and you ask them about their last 2 sex partners, and you might learn something about what they do, right? And that's the way that sexual network research has been done for a long time. The problem is that each of those nodes is linked inside another set of relations. And so this is real data on high school romantic relations. And what's interesting, of course, is that at the local level, these 3 nodes and these 3 nodes look identical. But at the global level, these 3 nodes are at much higher risk of getting a disease than those 3 nodes. And if you're a parent, I apologize. This is, yes,
harsh reality.
Right? It's like, whew, there you go, right? But on the other hand, whatever your mom told you when you're, that when you're sleeping with someone, you're sleeping with everyone they ever slept with. These kids slept with 288 other people in this room, right? So that, not in this room, I did this. So that's the point, right? Is that if you want to understand where something like HIV moves, you've got a lot more leverage if you know if they're in this cluster or in that cluster. Now, figuring that out in real time, in real places, and so forth is complicated, but it's the kind of thing that we want to know if we want to make any progress in these kinds of fields. As a general case then, we can replace this generalized contact with the network that's relevant for disease, right? And so the disease-relevant network in this case is the thing that we need to understand in order to make sense of this. Now, if you don't know the network, there are some conditions where we can estimate it really well, right? So if the network is perfectly random, if the links are sort of segmented into these really nice homogeneous compartments, or if it's a static graph that is random except for something like, some people are stars and some people are not, right? So there's a few sort of conditions where we could make sense of this feature. The problem, of course, is that most of these situations don't map onto real life. So most real life networks don't look anything like our assumed random networks, and so we need something else. The standard models tend to fail because networks change faster than the disease is spreading, the network admits to unobserved clustering that we have no sense of, or more importantly, there's some kind of active feedback between the disease spread and the things that people do to create their contacts. Right? And so this is a sort of what I think of as a really open opportunity for new research. As a simple example, this is a model that you might imagine that the disease-relevant network contact is a function of policy fatigue. Right? The first time, this we have over here, the index of days on the x-axis, and we can imagine that as a public health official somewhere, if I see a certain number of people get infected, I introduce new social distancing or lockdown measures, and then after the lockdown, people come through and they follow the rules, and the disease drops. All right, things are good again, so now the disease keeps going back up. But notice, my rule has stayed the same, but the peak keeps going up. Because people don't want to do it anymore. It sucked to be in lockdown. And so by virtue of that, right, even though I've reused the same rules every time, because of policy fatigue and people getting tired each time, you end up with this greater and greater amplitude of disease spread at each wave, even though your policies remain the same. So you have to have a policy that respects the fact that people have a fatigue element, and if they don't do that, you're going to end up with a greater disease than you might otherwise. This is simulated data, so that's my belief that it would happen. That's not real data. So there's lots of ways you can think about this. The real, of course, problem is that the disease-relevant network isn't a thing on itself. It's a function of beliefs, practices, family, work. That is, it's a function of all the human social systems that drive all of our behavior, right? That's what the network is created by. And so we need to understand what those features are. And so it's things like physical embeddedness, like where do they actually live, where do they have to work, what kind of belief systems do they have, how much agentic capacity do they have, to use the jargon of sociologists, that is, can I decide to stay home from work, or do I have to go or I will lose my house, right? So these are the kinds of things that we need to understand if we're going to be able to predict what this network is. So that's the connectionist point of view. It's all y'all trying to figure out where the pipes are laid so that we can figure out how the things are moving through the system. The positional analysis is slightly different, and it's more deeply rooted in sort of the historical social network or structural anthropology side of social networks. So imagine, just as a thought experiment, that I give you this little network, and I show you that there are two people in this network who love each other romantically, and they feed three people to bicker with each other. Any idea what this is? Right? We know, right? We know what this is. We know it intuitively. Like it's like, bing, there it is. This is Ozzie and Harriet's sort of classic sitcom family, right? This is the thing we know. And, if we want to distinguish, half my wife might say that really there should be another green arrow going over to this one, and then you can distinguish wives from husbands, right? So there's this distinction about what people do and how that shapes who they are. Right? And this is what's known as role systems in structural anthropology and sociology, that our roles are determined by our patterns of obligations with respect to other people. And so a role, I thought I had another slide on that, a role is fundamentally that I have some obligation to make sure my children don't starve. They don't have an obligation to make sure I don't starve, right? So it's an asymmetric obligation. And kids, that's what they do to each other, right? They sort of, that's how they fit. And so a role is determined by a role and a role complement. It's a pattern of exchanges. And if I know the pattern of exchanges, then I can figure out what the roles are. I can reverse engineer the rules that are guiding the system. What's really fun about this kind of work is that oftentimes the actors don't know the rules themselves. Families, they do. That makes a lot of sense, right? Like we know what parents are supposed to do. We know what cops are supposed to do. We know what teachers are supposed to do. Right? We have lots of formal roles. But there are also informal roles. Like bridges and leaders and followers and people that like solve problem solvers, right? So these things that are inside each organization or each community that people do, that they take on the role, right? And that role is emergent in a situation. And just like being able to see it here, we can reverse engineer it. And we know when someone has violated a role, whenever like they have that moment of embarrassment, or whether you like, of course the coffee's going to get made. That's what Gabe does, right? He's the coffee guy. He always gets this done, right? And so the knowing that that's the kind of thing that's there is something that we often sort of emerge at. It's an idea that we come to, even if we don't have a formal name for it. Questions or comments on these big picture issues? I'm going to shift gears just a little bit. All right. So I want to do a little bit of history of social network analysis in the field. And there's a much more detail in the paper that I might link to in the resources. But just as a big idea, I want you to, I liked, it's arguably a sort of a pathology of my field is that we can't give up our roots. But there's like, so the Moreno back in the 1930s is here. And if you think over time, these are just highlights of some of the key pieces that have driven where this field has come from in the last almost 100 years now. So I'm going to jump way ahead. I can't go through the whole thing. And talk about a few of the key pieces. In 1967, Rogers published Diffusions of Innovations. This is arguably the most influential book in social networks in the adoption of diffusions. And the idea was he figured out that you could segment populations by their propensity to adopt and their likelihood to share. And those two things would segment audiences into a way that if put together just right, you would get these rapid takeoffs. And so you think about what we now say something like going viral. He discovered, or he was one of the first to point out, that it's not really just that somebody puts something out there that's really titillating, but that there's an audience out there that's accepting of whatever that is. And if both of those things have to be there for this thing to take off. And then he builds a whole series of formal models for it and allows you to look at things like the spread of penicillin and stuff like that historically. At the micro level, there's been concern about things like peer influence, for as long as parents have had kids, because everyone knows that your kid's not bad, but their friends are really pains in the ass, and they convince them to do often things that they wouldn't do otherwise. And so Denise Kendall was one of the first people who really started thinking about the problem of selection versus influence. And this is a problem that's going to raise its head over and over the course of this week, which is that empirically, it's really hard to tell if you've convinced me to do something that I shouldn't do, or if I'm hanging out with you because we're both the kind of people that like to do bad things. Right? And so those kinds of features of selection and influence, Kendall was one of the first people to say, well, look, all this work we're doing where we just take people at their word that their friend is a bad influence is really overestimating the amount of social influence. And so she was a first break on some of the initial work on that. Berkman et al. Was one of the first pieces to focus on the fact that your networks, your social isolation, and the people you're connected to has an actual physical response on your likelihood of living longer. Right? So this is one of the first studies where they did a big follow-up over historically of looking at mortality by isolation and social support, and this has generated this entire field of social support in epidemiology and social epidemiology. In the early 80s, right at the rise of the HIV and AIDS epidemic, Richard Rothenberg and John Potterat and a bunch of others were really concerned, as was a lot of epidemiology at the time, that there was going to be a national heterosexual HIV epidemic that was going to essentially wipe out the country. And so there was this big push to start collecting data and figuring out what these things look like, where we might start it. And a lot of the ideas we have about implementing mitigation processes on networks in order to slow the spread of something comes out of this research. The other thing that John Potterat and Rich Rothenberg did is they created a bunch of data, and they were one of the first people to create these sets of public use network data on sexual relations that allowed us to model the spread of disease over these kinds of networks in ways that we hadn't done before. And it really opened the door to a lot of that work. It turns out, of course, that our networks and the things that drive health aren't just the spread of a disease or a contagion, but our networks get inside of our heads. And Bernice Pesca-Solido And a lot of her work on suicide and friendship and social embeddedness has created a whole literature of work about the way in which social networks affect our mental health. And so the driving of networks and mental health through isolation, popularity, peer influence, segmentation, notions of the veil, sort of a whole series of these ideas are under this rubric of Durkheim in our heads. So thinking the way our network gets inside of our heads and creates these outcomes. Once we had data, once we had processes, once we had these pieces together, we're able to do some work and think about the mechanisms that make some networks dangerous for the spread of disease and other networks safe. Martina Morris was one of the first people to discover this idea that networks can't be thought of as just static structures, if you think about the spread of disease, but instead they're dynamic unfolding structures, and the ways in which they unfold, the ways in which the dynamics are structured, ends up promoting more or less disease. And she came up with this notion of concurrency, that it turns out that a network, the amount of time that people are overlapping in their relations, that if you hold on to your past partner until you're sure of your next partner, like that little overlap creates huge disease spread risk. Whereas the same number of ties spread over different people or different timing can make a network much safer. So a very simple idea once you know it, but no one knew it at the time. Excuse me. A whole series of work on peer work that started on peer pressure and smoking is Ennett and Bauman's coming out of UNC. Tom Valente, who will be speaking here later this week, was a student of Everett Rogers, and he formalized the models from simple population models to actual network models. And so again, he's spent a lot of time thinking about the ways in which things diffuse through networks. He's also become arguably the world's leading expert in network interventions. That is, if we want to go in and experimentally do something in a setting to either change the network or change the behavior, he's the guy you want to consult with. My career started, and I think many of us have benefited from, one of the world's probably premier network data collection efforts, which is the National Longitudinal Study of Adolescent Health, now adolescent to adult health. It's in its sixth wave now, about to go into the field again for the sixth time. It first started in 1994, in which we collected data on over 90,000 adolescents in their schools and asked all their social network ties, including sexual network ties. The ties you heard that first slide I showed you was from this study. This is from Ad Health. We didn't misspell it. There's supposed to be two Ds because it's a pun. We're trying to add health to the population. Never try to make a study named out of a pun. That's not the best idea. But if you haven't already used Ad Health data, you probably will. You're going to see a lot of examples of that today. It's actually remarkable data set. The field shifted again in the mid 2000s when arguably there was a methodological turn. Prior to this, so the work all the way up through Ad Health, and prior to this coming out of folks like Stanley Wasserman and other sort of old heads in the field, was classic applied graph theory. You would take the network, you would map the network, you would think about the network, and you would describe it. Statisticians thought, well, that's great. You can tell stories all day. How about if we test something? And Mark Hancock, Martina Morris, and a few others, building on work, Carter Butts, building on work coming out of formal spatial statistics, figured out that there are ways to model the dependencies in networks formally that can create a really rigorous test for the structure of a network. And this work really changed the way that many of us do our work. And so you're going to learn a lot about these tools. The StatNet project is still one of the main ones we use. This is the Ad Health network I showed you a minute ago, which happened in there. And then the diffusion ideas really took off, or really sort of took off to the press when Christakis and Fowler wrote this piece on the spread of obesity over 32 years. They had data on that wasn't meant to be network data. They found these data. Everyone familiar with this study at this point? Okay, so just that it was kind of remarkable in that this was the, I can't remember the, what, please say it again. Framingham, yes, thank you. Framingham. So there was a Framingham heart study. And they originally asked everybody these questions about who they spent time with, who they were connected to, because like all good longitudinal studies, you're afraid when people leave, you want to find them again. So these are really just nosy questions like, all right, if I can't reach you, like who's the next person to know you? And so they took this data, and it turns out people named their brothers, their neighbors, their other family members. Excuse me. And they were able to put together this network, this latent network of people who they're connected to, and then follow that network over the course of 50 years or 30 years. And what they discovered was that when people gained weight, so did their peers, right? And because the sample was such a dense sample in this one geographic area, they actually had a pretty good coverage over the whole network. Now, to social network researchers, this wasn't particularly innovative. This makes sense. We expected that. Like if I decide I'm going to eat cheeseburgers and fries, like you'll probably go and eat cheeseburgers and fries with me, right? Economists hated this study. Doctors hated this study. Right? The level of vitriol that came out of this study was remarkable because they were making an actual epidemiological causal claim. They were saying that my obesity caused your obesity, right? So that kind of a causal frame just sent the hairs on the back of the neck of every economist in the room up. And they were like, that can't possibly be true. And so they spent all this time trying to debunk it. And arguably, if I were Christakis and Fowler, I'd feel pretty good about the results. They did we'll talk about it in depth later, but what it really did, and the reason that I keep this in this list, is because it raised that the controversy over this study raised the level of rigor for the kind of work we do by an order of magnitude. The kind of work you have to do to make these kinds of claims is now much stronger, and we now have the tools to do it better. And so all of those things have happened because of this work. Tom Valente's work then sort of compiled all this, and he gave rise to some of this very workshop we're doing with social networks and health. And of course, this work has just continued. And this is, like I said, the corpus of studies that have been working on these kinds of projects has just been growing dramatically. Now, this is not a particularly fair study because the corpus of studies in general has gone up as well, but there you have it. If you wanted to understand the field of social networks and health in general, one tool we can use is to map the network of papers that are like each other, and that's what this is. And so you can imagine I find one paper, the analysis of human papillomavirus, or HPV, being discussed in MySpace, so this might be a somewhat older paper, right? And that paper is similar to a set of other papers, right? And you can see they're similar to a set of papers like, after all, it doesn't kill you, so quit smoking or something. And so these papers have something in common. In this case, what they have in common is they use similar words. If you were to take this local network around that one paper and spread it out, you'll see that there's some set of papers about smoking, there's another about health blogs, there's a whole bunch of papers about HPV. Right? This paper sits between a lot of those papers. Well, we can then aggregate up from that and keep aggregating and spreading out until we see the entire landscape of social networks and health literature. And that's what this is. So this is exactly like that network I showed you before, so it's a spatial representation, but because I don't want to put 85,000, is that right? Papers, 18,000 papers on the screen at once. When said, if there's a cluster of papers, it's a topographic map. For the hikers in the room, this should be something you see. So you can see, right, that there's a big hill around studies of HIV, another study of social capital, all the social support work. And what's nice is you can think about what characterizes this field. And so there's a whole set of papers, right, that we can then cluster and think about, well, what is inside each of these papers? And so the field is being driven by lots of these different topics. Rogers' diffusion of innovation, like that work is being cited all over this field. So this is which activities gets done. And so the notion of things spreading through a network is part and parcel of the entire field. Valente's work has really been focused on adolescence and influence. That's where he's had a lot of his work, but also because of the intervention stuff over in health policy. Christakis and Fowler, that's really been driven in this world about social support and social capital and the ways in which that's been affects the health that we have. Whereas Martina Morris's work has really been central to the notion of discussion about HIV and the spread of sexually transmitted diseases. House's work on social relations and health, of course, is the key site in the social support literature, where Provon's work on network effectiveness is driving the field about health systems research. Ad health, as you might imagine, is driven by the adolescent network set. Arguably, that peninsula wouldn't be there were it not for the ad health data set. You can also then think about different authors. So someone like Ed Lauman, who's really a key feature in aging and sexual health. Most of his work is spread all over this set. Bernice Pescasolido in social support and mental health. We can also think about the kinds of topics that are being covered. I think we have a really nice distribution of studies of race. So health disparities by race is a feature across networks and thus across all of the fields of studies using networks in social health. Surprisingly, I think that gender is not much of a concern in the health policy side, which I think is probably part and parcel of the reasons that we see what we refer to as structural gender inequality in the health policy and health intervention systems. Is that we think about gender as an individual level feature, and that's reflected in the kind of work that's been done. And then you can see this by disease as well, right? So some parts of these works are focusing on different kinds of disease. I think one of the things that I want you to think about in this is just to realize that you're stepping into a rich field. And if you want to study something, right, there's probably some work that's there. And so we can help you find it, you can think about it, and just respect the fact that there's a great literature here to build on and a great community you're jumping into that I think have a lot to be done. But also, to think about this kind of a map, again, if I find a version that's clean, this kind of a map is in many ways a real map. And unlike sort of the geographic map that we're used to, there are still regions of this map where there be dragons, right? We haven't really explored them yet. And so you can find your way out and push the boundaries of this space to make sense, like what's going on in the interstitial spaces, right? To really dig down and explore and to become the next person that's driving the new growth and the new change in these fields. And that's where I hope you go. All right, a little bit about today itself. This is the sort of social networks research flowchart. This is what we do. And this isn't particularly key to social networks. I think people tend to do this in any kind of empirical field. But you have some research question, you collect some data for it, you figure out what's going on with that, right? Some kind of exploratory data analysis, you then come up with a model, you get your results, and that reshapes your new process. So this is the standard scientific method, right? And the amount and the extent to which your research question is more or less well formed is the structure of the theory in your field. Kind of exploratory analysis depends on where you're there. But that's what we're going to do today. And so each of the blue bars, not today, this week. This is the map of what we're doing, right? And so right now, we're in sort of the research question stuff. But we're going to pop up a lot over the course of this week. Different kinds of people who are going to raise good questions about the kind of work you should do and the kind of work that's important to be done. We're going to have a lot of discussion over data collection. Today and tomorrow are really focused largely on base methods and data collection, and how to organize and deal with your data. So how do you clean your data? How do you manage it? What do you make sense of it with? Once you have data, we typically score it. And so there's a lot of work being done on just building metrics and describing what those metrics are. These are probably the most unique social networks are. This is like you probably haven't heard this before if you haven't done network stuff. And then we'll talk a little bit about visualization and clustering and sort of ways in which to build these exploratory elements. We're going to spend a lot of work on modeling. This is both the arguably the most dense part of the week, but also the part that you're hopefully going to take with you and allow you to get your work done. Does it feel like a bit much? Right? This will be a week of drinking from the fire hose. So a little bit of strategy. I recommend that you focus on ideas and big picture issues, right? So really sort of focus on the questions that are being asked and the broad outlines of the process that we're doing. You don't need to take notes. Like everything's recorded, both video and like you have access to all the slides and all the code and everything like that. So focus on understanding, right? So you'll get a chance to then get at the details on your second pass. Don't get lost in coding. Many of you think that you're here to learn coding. You're not here to learn coding. You're here to learn networks, and we're going to show you some coding. And we're going to give you some examples of coding, and we're going to give you some pieces you can take home. And part of the reason for that is that code is really easy on the long run, once you know a little bit. You had a chance to play with ChatGPT, for example. I said, if I give you an edge list, can you draw me a network? Sure. right? ChatGPT always says yes. I've never had it say no to me yet. It's like that friend that is completely enabling. But there you go. So put it in. I said, all right, here's the data. Show me what you got. Great, here we go. He's going to run it, see what you have. A little bit of talk, and there you go. So I could say, this machine is going to put me out of business, right? So this is what we're like a whole week. He has it right there, right? And so we can do this, right? The key is that you need to know what question to ask him, right? And so the code will be generated. ChatGPT will do it for you. You can get the code if you know what question to ask. So focus on we're going to give you examples, and you need to check it. Like, he makes stupid mistakes. I don't know what's the gender of ChatGPT. But the point, of course, is that don't get lost in that. Focus then on the details, right? Focus on the big picture, and it'll get you right there. All right? Okay, let's take a quick break, like 5 minutes. Stand up, move around, say hi to someone you did before, and then we're going to move to network data structures. So we're going to figure out what the elements of data that we're actually working with are. And so we're going to talk through networks. What we're going to do before the break is the next break is we're going to identify the types of network data and sort of the basic network structure features, things like components and things like this. So that'll make sense in a minute, but maybe not a minute, 50 minutes. So, Gabe wanted me to make sure that we know that if you have any questions throughout these pieces, Gabe, say hi. Gabe's the guy with the beard. Say hi, Gabe. Gabe was making sure to remind you that that there's the Slack channel is being monitored. So there's questions you want to ask, you throw them to the chat channel. Otherwise, raise your hand, and people around here will answer them the best we can whenever we get to the point where there's questions. And of course, for me, interrupt at any time. If I'm like, I talk really fast, you're all smart. I assume you're going to listen fast, but if not, then interrupt me, and I'll slow down and make sure we get where we're at. All right. So we first need to talk about the unit of interest of networks. So the unit of interest in network analysis is the combined set, the joint set of actors and their relations. So network analysis is a combination of two data sets. Actors are represented by points, and relations are represented by lines. Actors, depending on this one thing you're going to learn quickly is that this field is jargon rich. You can think about actors as people. That's what most of it is for us. But also, formally, they're nodes, they're vertices, these points. You'll heard those words all the time. Relations are referred to variously as edges, arcs, lines, ties. Like, all of these things are equivalent. And a classic example, the example we're going to use today is this little network here with five points. Looks like 5 points and 5 lines, right? 1, 2, 3, 4, 5 lines. So, in general, a network relation can be, the basic unit is an undirected binary graph. So in an undirected binary graph, A is connected to B, and B is connected to A, and there's no distinction of A or B as far as one or the other. The classic example of this is in the same room as, right? So A is in the same room as B, B must be in the same room as A. Sex is a binary variable. If I've had sex with you, you've had sex with me, right? So relations are oftentimes necessarily symmetric, right? A valued relation is where you think about the number of times or the frequency with which something is happening. So in this case, if this was a sexual network, again, it's necessarily symmetric. If A has sex with B, B has sex with A, and A and B have had sex once, and B and C have had sex 3 times. And you can just indicate that in this case with a value over the edges if you wanted to, or, which is more common, to use thicknesses of lines or something like that. The second dimension is then whether or not the relationship is directed or not. So a directed relationship means that there's something I do to you that you may or may not do to me. Right? And so liking is a classic example. So I like you, I hope you like me, right? So that would be a reciprocal relationship. So in this case, A likes B and B likes A, and so it's reciprocal. In this case, C likes B, but B does not return the liking of C. So poor C is left in the cold, right? And so lots of relations have this kind of feature, right, where it's known as a directed graph, and so the relationship is directed, and it's an empirical question as to whether or not the relationship is symmetric or not, and whether or not it's reciprocal, and that's of interest. We tend to think, for example, that if in relationships where people have a reciprocal liking relationship, that peer influence is going to be stronger than when they have an asymmetric relationship. Now, again, you can be flooded this. There are some relations, we tend not to deal with them very often in sociology, or in social networks and health, but there are some relations that are anti-symmetric, that are necessarily directed. So for example, boss of. If I'm the boss of you, you aren't the boss of me necessarily, right? And this will come up in animal hierarchies, right? So if one person is dominant over the other, if I'm a dominant chicken over you, right, then a dominant hen cannot be dominant to each other, right? So there's a clear dominance ranking in those cases. Now relationships need not be single items. They can be what are known as multiplex. So we can have, so on any set of nodes, we can have any number of relations. And so I might have liking, I might have friendship, I might have jealousy, right? There's lots of different things that can occur on a network. We refer to these as multiplex networks. This is a subtype of what's also going to be called a multi-layer network, in which you have multiple different types of relations in which things can move. And so it might be that my coworkers are one relation, my family is another, and the people I wish I were yet another. Right? So we have lots of different relations that you could map onto a network. Once you have the set of nodes and ties, that gives you a network. Well, we also care about the scope, or the size of the extent to which, the extent of the population that the network covers. The simplest network are data we refer to as ego network or local network data. And local network data is usually an individual and their direct contacts. And they're treated in isolation. So I'll go out and sample people and say, tell me your 5 best friends, and then ask you to tell me about your 5 best friends. Do they smoke? Do they have a college degree? We'll ask a whole series of questions about those. And we're going to have a whole first half of the day tomorrow on ego network data. There's a lot of advantages to ego network data. We're not going to spend most of the system stuff we talk about today, aren't really focused on ego network data, but in many ways, because of the statistical turn in networks, ego network data is really nice because you can sample ego network data with all the anonymity and confidentiality that comes with ego network data, and then simulate global network data that is consistent with the two and get the best of both worlds. So that'll be on Thursday, but just a little preview. Partial network data is the most common kind of partial network data. I mean, that's a catch-all term, right? But what I'm referring to here are some set beyond ego, but not the entire population. And the way you usually get this is through some kind of contact or link tracing. So if I find somebody that is doing something that I'm interested in, such as intravenous drug use, for example, that's a hard sample to draw. I can't go out and just sample everyone in the population and hope I get a bunch of intravenous drug users, because they're rare events and they don't like to admit being intravenous drug users, right? They need a little bit of trust before they're going to tell me who they are. And so we'll often do snowball samples. So I'll start with somebody from a clinic, they'll have trusted the researchers, and I'll say, hey, tell me who your friends are that you do drugs with. We'll go talk to them, and then they'll tell them that I'm trustworthy, and then they'll go off to the next, and we'll do this sort of snowball set. What portion of the population that captures or not is often unknown. We have formal methods of doing this, right, which is known as respondent-driven sampling. And when you follow the rubric of the respondent-driven sampling, you can actually do some good inference on what the population looks like. And we'll talk about that later today, I think, actually. Ashton's going to come talk about that. Most of the methods that we are going to talk about assume that you have what's known as global network data, all the data relevant for the population of interest. So it might be all kids in a classroom, it might be all intravenous drug users in a city, it might be all judges on the Supreme Court, right? So there's lots of different ways you can define your relevant population. But then you care about all the relations inside that population. Now, many times, our theoretical global population is anybody who could get HIV in America, right? So that's a huge population, and we don't actually have that. So we typically have to have some way of thinking about that network. But the assumption is, within some relevant boundary, we have the network. Visually, then, you can think about these as being just different parts around an ego, right? So we have the ego here in red. Ego is the jargon word for your respondent in network analysis. So we have our respondent. They've named people that are their contacts. They might have one best friend, right? So you have a best friend dyad. You have an ego network. We also have these things called primary groups or communities. These are people that a person spends most of their time with. And we're going to, oftentimes the primary group is your community has a special relation in terms of its influence on your behavior. And so understanding what that person's community is often good to know. Then you have some level of partial network where you've snowballed out from your ego. And then the whole thing would be the global network. A key feature of a global network that you're not going to get in most partial networks is that it's possible to be isolated. Right? One of the advantages of defining your boundary first and then asking about all the relations within that boundary is that some people don't have relations. Right? So some people are socially isolated. And if your goal is to figure out how the social relations affect behaviors, and you do a snowball sample, you're going to miss all your isolates, because definitionally they don't have anybody that's tied to them who's bringing them in. So you got to make sure you have a way to do that. Questions, comments, thoughts, concerns at this point? All right. We're just going to keep layering complexity. So we'll make sure we're running before we're walking before we run. So most data, when you think about network data, we think about the connections, the direct connections between actors, between people, between states, whatever our unit is. These are formally known as one-mode networks, that every person in the set, a mode is a type of person, all right? So a type of a node. And so a one-mode network, what that means is that everybody in the network could, in theory, connect to every other person in the network. There's no reason, like logical reason, that it's impossible to connect to the others. An alternative to that would be something like a two-mode or a bipartite network. In a two-mode network, it's only possible for relations to cross categories. And this is usually definitional. So you might have people as authors and papers. An author, right, is connected to a paper, but a paper is not connected to another paper directly. A paper is only connected to another paper through an author. Right. And so people and groups, authors and papers, words and ideas, events and people, like all of these things, they're categorically different things. And by virtue of being categorically different things, one is usually a member of the other. The beauty of two-mode networks or multi-mode networks, all right, so this is a classic sociological example. It was collected in the 1940s or 50s. It's called the Southern Women's Data Set. It's a classic case of women. These are the ladies who lunch. So this is a data set literally of Southern elite women and who they had lunch with on some given evening, some afternoon. And so what you have are two modes. You have a person mode of ladies who lunch, and you have another mode of events, of lunches that they could have gone to. And so this is a bipartite network, and what's key about a bipartite network is that there are no ties from yellow nodes to yellow nodes, or from blue nodes to blue nodes, but only from blue to yellow. So, all right, great, Moody, what am I going to do with that? There's two things to keep in mind. The first, perhaps an obvious one, is that there are some structural constraints here. You can't have certain size loops, you can't have certain size paths. Like there are certain things that are constrained by virtue of the network being two-mode. But more importantly, is that this represents what's known as a duality. That information I have on people is the dual of the information I have on events, and I can project one into the other. So I can think about the number of lunches that women have together. And this is the one-mode projection of a two-mode data set. And so I can ask, how often does Flora and Olivia share lunch compared to how often Flora and Laura, to rhyme, share lunch, right? And so this allows you to create an interpersonal contact network or a likely contact network from an event data. The dual of this is I can ask which events share people. All right, so now I figure out that lunch 14 and lunch 12 shared more people than lunch 14 and lunch 5. In fact, no one who attended lunch 14 also attended lunch 5. Right, so these are separate sets. And this is kind of cool. It turns out that lots of things in social life have these dual characters. That you think you're talking about lunches, but you're really talking about women. And these things are the flip side of the other. One's that you look at one's the head of the coin and the other's the tail. Knowing one tells you it is implicitly conditional on your understanding of the other. And so that's the notion of duality. One of these things is also conditional on the other. Practically for us is that real one-mode network data, like who do you talk to all the time, it's expensive, difficult to collect, there's a bunch of IRB issues, it's like out there all the time, it's a pain in the ass. Two-mode data, it's just there, right? There is more two-mode data that you can shake a stick at. Every survey you've ever analyzed is implicitly a two-mode data of people connected by their similar answers on a question. So if Dana and I answer a question the same way, that's going to say that we're probably going to behave more similarly than people who didn't answer the question the same way. People who go to the same lunches, people on any office schedule. If any of you work in hospitals or study hospitals, the work schedule, the day-to-day work schedule, is an implicit social network of people overlapping by shifts. Those are the people carrying hospital-borne infections from one room to another. If you know who work together in the hospital, you got a pretty good bet of where infection is going to move in that hospital. Right? Same thing in nursing homes and so forth. This is the data set that Lawrence Castellino and I put together a few years ago now. We used Medicaid data to look across the entire country. I just zoomed in here on this one hospital in Philadelphia, or some city in Pennsylvania. And we're looking at this one hospital. It turns out that we created a network of people who shared patients. So each node is a doctor. Each line is the number of patients they had in common, and that they both jointly treated. And you can see in this particular hospital that it's one hospital, but there are two practicing communities. These are all heart patients that started, so they're not different fields. So if you get admitted to this hospital, you're either admitted to the blue treatment group or the red treatment group. And it turns out that of multiple communities in these hospitals, the readmission rates are very different. So it could be that you get lucky and you get the hospital, you get the treatment group that performs well and you're going to be fine, or you get the treatment group that performs poorly and you're going to die. Right? So this feature is a hidden element underlying in a hospital network of this referral. Perhaps it's a referral, perhaps it's a shared expertise. We don't know. We didn't have that part of the data. But it's a hidden community inside the hospital that affects healthcare outcomes. And so if you have data on patients, you also have data on physicians' networks. And you can then ask questions about how their treatment conditions differ. Questions, comments about types of data, modes of data. And it's sort of two-mode is the easy. You can see that. But you can have three-mode. You can have K-mode. You can go as many layers as you want. Questions, thoughts, comments, concerns? All right. We've been working now thus far with pictures. Pictures are great. I like pictures. It's hard to do analytic operations on pictures. So we need a data structure that we can actually work with. And so the classic way to represent network data is known as an adjacency matrix. And so in an undirected binary matrix, this is just a two-dimensional array. So you have all the nodes down the rows, all the nodes across the columns, and they're sorted in the same order. So a tie, a value here, a 1, means that there's a tie between A and B. And because this is an undirected binary network, it's either on or off, and whatever's above the diagonal is mirrored below the diagonal. So you see that that's the same, those are the same. So it's a symmetric, undirected, or unvalued network. If I have a directed binary network, you'll notice now in this case that the convention in sociology is to have rows be the senders and columns be the receivers. So there's a tie from B to A would be here, and from A to B is there. So here we see that C sends the tie to B. That's this one. But we find that B does not send the tie to C. And so it's from on the rows and it's to on the columns. If you have a valued network, you just replace your binary indicator with a number, right? So pretty straightforward. What's nice about matrices is that matrices are great for doing math on, right? If you dust off that moment of your high school matrix algebra class back in your brain, remember what an eigenvector is and all the rest of those things, right? And how you multiply conforming matrices, right? All of that's in there, right? The beauty of an adjacency matrix is that I can write an equation in matrix form with the adjacency matrix or some transformation of it as an element. That's really useful, right? We're going to use that a lot. The problem with adjacency matrices as a data analytic feature is that they're really inefficient because the vast majority of our networks are what are known as sparse. So most of our networks have many more zeros than they have ties. And so where the number of possible relations on any network goes up with the square of the number of nodes, by virtue of it being a network, and the fact is that the vast majority of these are empty. And so you don't want to store a bunch of empty elements in your data set because it just takes up unnecessary space. And so instead, the two common data elements we will typically use are either an adjacency list or an arc list or /edge list. An adjacency list is just one row for each respondent in your data set. So here I have 5 rows because I have 5 nodes. and a variable or a column for each relation they have. So person A is tied to B, person B is tied to A, person C is tied to B, D, and E. This is just a rectangular data set. So you've all played with those data sets if you've ever used Stata or any other sort of standard network analysis or analysis. Any standard data analytic sort of table, that's just a data frame of people and their relations. You know, first relation, second relation, third, and if you don't have it, it's just a missing NA or something like that. These are really efficient ways to store data, and a lot of algorithms use this because if you replace these letters with row numbers, and so if person 1 is tied to person 2, I can do a walk through this little data structure by going from 1 to 2, jump down to the 2 row, jump down to the 3 row, jump down to the 4 row. I can figure out where things are by virtue of how it's indexed in the adjacency list. So it's a really useful data structure that you will never have to worry about unless you want to write some algorithms yourself. Right? And if you want to do that, you probably wouldn't be here taking this class. So you can put that behind your head. But anyway, it's a nice data structure for that. One of the problems with this data structure is that if you have a valued network, you have to know that the first column here, what value that is in yet another column. So you need a new column for each relation that is the exact mirror opposite of this. And it's not difficult to screw that up. And so you want to make sure you have that right. A simpler data structure is known as an edge list or an arc list, in which you simply have one row for each tie in the network. And the beauty of this is that you have all the information about those edges you can just carry with you. So if I have a valued relation, I can just say that AB is valued at 1, CE is valued at 5, ED is valued at 1, and that's just a new column on the arc list. If I want to say what kind of relation it is, I have another column. If I want to say how frequently it happens, I have another column. If I want to say its start date, its end date, like any characteristic of the arc list, I can just add on as a column to that data structure without having to worry about the coordination between matching up the things on an adjacency list. If you have a two-mode data set, then the issue is that you have the same idea, it's still a matrix, it's just no longer square. And so in that case now you have some set of rows across the column, which is your first mode, another set of rows, which is down the rows is the first mode, and across the columns is your second mode. And this, in order to distinguish it between the square sort of symmetric thing that we typically refer to this as an incidence matrix as opposed to an adjacency matrix, but it's the same basic idea. When you registered for this workshop, we asked you to tell us what you were interested in. This is the two-mode network of you and the interests you listed. So if you sort of look carefully, you should be able to find your name somewhere. And then you can see that some people, for example, are listed in mortality, some people in race, some people in mathematical models, right? So we have a whole series of two-mode connections, which we can then turn around and say this is the one-mode projection of your interests and your data. All right, we're going to take a quick break here in a minute. I have a few thank yous I need to give before we jump into the other elements. First, the DNAC RAs. These are the folks in the blue shirts you see out here. Emily Harity. Emily is here in the back. Gabe. We already met Gabe a minute ago. He's already busy with someone else. Madeline, you've seen a good deal of time today. There's Madeline. Madeline, and you probably got an email from Madeline at some point today. We have a whole series of DNAC alums. These are folks that have come back to visit us and help us out today. John, Dana, Tom, Leanne, Lane. Raise your hand, say hello to everyone. There we are. The DNAC RAs and alums are here to help you. Right, and to help me. I couldn't possibly do this, and we couldn't possibly do this work without these folks. And so we really appreciate all their help and all their care. Be nice to them. They're really, they're not quite volunteers, but you've all been RAs at some point or another. You know what it's like. So we really, really, really appreciate the help. Everyone's here to be as good as we can. Be kind and thankful, and we really appreciate your help, so thank you. We are guests of the Rhodes Information Initiative, IID, and Rhodes is, they own the third floor of this building. This is their room. They are doing work out there. Kathy Peterson is the woman you've seen walking around, helps with some coffee bits. We are guests, so act like guests, right? So we really do appreciate all the work they've done. This workshop is co-sponsored by the Duke University Population Research Institute, or Dupree, Bernie Fisher in the back, is one of the key staff people at Dupree. Linda, I don't think is here today, but Melinda has also helped with some of the billing and things like this. The Social Science Research Institute is downstairs. They also have free coffee during the day, so if you're interested in getting coffee, they have that. And they also tend, especially this time of year, because the classes are out and the new Data Plus folks haven't started again, there's also a little bit quiet down there. So if you want to, during one of the lunches or something like that, when you have some free time, you want to go talk, feel free to go down there and find a table and get a cup of coffee. And of course, this wouldn't be possible, this entire workshop would not be possible without the support of the NICHD. That's our grant number. Roz is our program officer. If you find that this is a great workshop and you really love it, I'll give you her email address and you should send her and say thank you. If you hated it, we were funded by DOE, so you can talk to them. We will be doing, and seriously no, we will be doing evaluations at the end of every day. And those evaluations are really important for us because we have to write a report to Roz every year saying, look, we did this stuff and we did great or we did poorly and we're trying to fix it. And so please do, you'll get those emails, we'll put it out, we'll put a link on Slack, probably be the simplest, I'm guessing. And so we'll put that out there. If you could fill that out real quick, there'll be 1 or 2 questions, for each of the sessions, just, what did you like, what did you dislike, those kind of things. And that really does help us out a lot to make sure that we can get our report in at the on time and keep our funding going and get the next generation of folks in here. Any other elements of organization or that kind of feature that we need to worry about right now? Madeline?
If you haven't joined the Slack, just join the Slack.
Yes, that's right.
Other things on there, like we're going to make a poll for, we haven't decided, there's a couple different options for Wednesdays when people event. We have a couple different things we might do. We might split into 2 groups. So, if you want to put in your input on what you'd like to do on Wednesday, then have to join the Slack.
That's right. So we have some fun activities happening. Wednesday is still up for grabs. Thursday is the traditional North Carolina barbecue. So again, not required. None of this is required. This would be fun and enjoyable. But hopefully you can join us. We have beer and pig on the deck downstairs. If you don't like beer or pig, we have alternatives. So that's the idea. All right. Okay, we will start back. I went through that a little faster than I thought. The next one's scheduled to start when? At 11. All right. So you have a half hour between now and the next session to start. And so get some coffee, maybe go outside, see if you can hear some cicadas, stretch your legs, meet somebody new, and we'll see you in a bit.